Stay right here.
Right here?
Yeah.
Hey. You're good, you're good.
3, 2, 1.
I'm spinning! I'm gonna get you, Nathan!
Can I go up? Okay, Mr. Azer, so how we ended up finding our rotational speed was through the equation F equals omega squared I plus 2 alpha delta theta. And in order to find that, we measured how many times Zachy rotated, and that turned out to be 2.5 times. So it was theta, delta theta equals 2.5 pi. And then we needed angular acceleration, and in order to get angular acceleration, we used the formula angular acceleration equals regular acceleration over r. And then in order to get regular acceleration, because we needed to use the equation delta y equals 1/2 acceleration times time squared, and how many seconds the video took. And so we found that a equals 2 delta y over, we had 7.25 seconds of spin time, and so our acceleration turned out to be 2 times the height of the balcony over 7.25 squared. We plugged that back into our equation with alpha, and then we ended up plugging that equation of alpha into our equation with omega. So we got omega squared equals 2 times quantity of 4.29, which was the height of the balcony, over 7.25 squared, divided by 2.225 squared, which was the radius, times 2.5 pi. Since our original angular velocity was, after we found omega, we plugged it into our energy equation and solved for I, and we ended with, we changed our original equation to be I equals 2 mgh minus m omega squared r squared over omega squared, and we plugged in all the values for that, and we found that I equals 1.61122 kilograms meters squares. Could you explain our setup?
We had a freshman sitting on a chair, Zachy Rosen, and the chair was attached to a string that was wrapped around it. And then we dropped a 1-pound weight down a balcony, and then the weight pulled the string down and it unwrapped, causing the chair to move around. We were able to measure the moment of inertia of Zachy Rosen.
Yeah, so part of our math in our original calculation was doing conservation of energy, and so we started with U, which is the potential energy that the weight had at the start, equals k rot plus k. The k rotation is Zachy's rotational energy, and the k is right before the weight hits the ground. It's maximized its k. And so we solved for I because we were looking for Zachy's moment of inertia, and we ended up getting I equals mr squared times the quantity of 2gh over v squared minus 1. Some of our errors, have we accounted for all potential outside forces and torques besides those that we are counting on to give you a good data?
Okay.
Yeah, so we have the torque of Zachy spinning, we have the torque of the pulley, and then we have the force of gravity going down, and then maybe the force of tension on the rope. Because we hope that the rope won't slip, we have the force of friction on the pulley. However, during our experiment, the rope actually slipped off of the pulley, and so we actually had to make some adjustments. And this goes into our error. So our sources of error were time, because it's hard to judge when exactly the weight stopped moving and when it started.
Human error.
Human error. We had the pulley that was also a sensor for rotational speed. That was a big source of error because actually the rope fell off of that, and so we need to sort of dance around that problem and figure out how we were able to, and figure out rotational speed on our own. So we counted friction on the pulley and later on the balcony ledge as negligible because we didn't want to work with it. Yeah, we just counted it as negligible.
We would like to acknowledge Zachy Rosen for being a wonderful freshman on a chair, Nathan Kushner for the wonderful filming,
Yeah.
Josh Simon for a one-in-a-lifetime appearance.
No?
Wait!
Caden Toker for making sure that no one got hit when we dropped our weight. The position that we were measuring Zachy in was like this. So very slim, center of mass, cylindrical type position. not to complicate anything, with his arms out or anything like that. Our inspiration was a problem from our homework from the AP Physics book. Thank you, Miss Azer.
Thank you.
Watch out! Oh shit, I'm getting it.
All right.
Go!